Fun Sock Friday, the 13th of November. SOBA students will be able to graph parallel and perpendicular lines. Heads up, we're looking at a test next Thursday, okay? We're looking at reviewing Tuesday, testing next Thursday, okay? Parallel lines. What do we know about parallel lines? They never intersect. They're lines that are in the same plane that do not intersect. Okay, they never, ever touch or cross, okay? And they're called parallel lines. Now, we have a symbol for parallel lines. It looks like this. Do those just kind of look like two mini parallel lines? Yeah, okay, it's just two slashes. Another way we do the symbol sometimes is straight up and down. It's less common, but you can still see it from time to time. Okay? Okay. You don't normally see them because that's just an equal sign, side to side. But great question, okay? Yeah, I guess you could say it's an equal sign, okay? So these are two symbols we use for parallel. They're both used, okay? Yes, Abby?
Do they ever use it like split to the other side?
No, I've never seen them that way. I guess maybe it could be, but I've never seen it that way. Great question. Hey, where we, let me try that again. Where do we see real world examples of parallel lines? Raise your hand for a real world example. Okay, Haven?
In the real world.
Okay, in the real world, good talk. Okay, Abby?
The roads.
Okay, the roads, like the lanes on the road, okay, the lines on the road, okay? But overall, okay, guys, voice off, okay? Brady?
Shapes.
Shapes? What do you mean like shapes?
Like squares.
Okay, like squares, we see the size of a square, okay? Corny?
Railroad tracks.
Okay, railroad tracks, okay, you have the long ways, but you also have the side of the railroad, right, Alice? Okay. Yes, Ellie?
Towers.
Okay, towers, like, what do you mean?
Twin towers. Well,
Okay, so they were like parallel lines, okay? Jocelyn? Okay, longitude and latitude lines on the map. I like it. Yes, Jaden.
Adidas.
Okay, Adidas, the three-stripe life. Okay, you can look at my shoes. Okay, Isaac, the flag. The flag has parallel lines. Okay, Haven. Buildings. Okay, like the sides of the building, they better not touch. Okay, or like the floor and the ceiling, they better not touch. That would be bad. Okay, Alice. For the lanes. Yeah, actually what Abby had said earlier. But yes.
Roads. They burn.
Okay. Anyway, okay. Voices off. So we see a lot of different parallel lines in nature, okay? We can also look at lines at the ceiling, lines on the floor, okay? Parallel lines,
Have the same slope.
they do have the same slope.
Yes, they do.
Okay? Now here's why they have to have the same slope, okay? Because if they didn't have the same slope, then they would intersect. Like, let's look at this. Let's say there's just this random line here. You don't have to draw this. There's this random line here. And there's another line with like a slightly different slope. They're both positive slopes, but are those slopes slightly different as these two lines? Yeah, they increase at slightly different rates. Now, do these lines touch right now where you see them? No, but they will. When we continue them on, they're going to touch, okay? Meaning they're not parallel. For them to be parallel, they have to have the exact same slope. Okay, we'll pretend that those two do. Okay, they would have to have the exact same slope. Not even these two wouldn't. Okay, but we could pretend that Mr. Crossell drew it right. Okay, that's a lot better. Okay, so we can pretend we can say that these lines would never cross because they have the exact same slope. If they're even slightly off, they will eventually touch. Okay, does that make sense to us or no? Okay, maybe, okay. So, all vertical lines, if lines are vertical, okay, they're going to be parallel because all vertical lines have undefined slope. We talked about how that U looks like a V for vertical, U for undefined, okay? And all horizontal lines are parallel because they have the slopes of what? Zero. Because the second letter horizontal, O looks like the zero, okay? So all horizontal lines are parallel to each other, kind of like the stripes on the flag, okay? And vertical lines are parallel to each other, okay? Alrighty. Let's graph a line, okay? So here's what we're going to do. We want a line that goes through this point, negative 2, 4, and we want it to be parallel to this line. So this equation we're given, y equals 1/3 x minus 3, that's a line, okay? And as a matter of fact, you don't have to graph this, okay? As a matter of fact, okay, this line would be right here, okay? This line would be right here. Now, we don't want that line. What we want is we want to graph a line that's parallel to it, so it has the same slope as that line, but we want it to go through this point. Okay? So we want it to go through this point, but be parallel to this line.
What?
Okay? So if we wanted to go through this point, a good first place for us to start is to graph this point. Negative 2, 4. So let's graph that point. Negative 2, 4. So 2 to the left, 4 up. Then the purple, I do want you to graph that. Negative 2, 4.
Oh, wait.
What? Wait.
Okay? We want it to go through this point. We want to graph a line that goes through this point in the purple. So I'm going to graph that point because we want that point on the line. Our goal here on this problem is to graph a line. Now specifically, we want the line to go through this point and we want it to be parallel to this line given by the equation, which is in the pink that we see right here. We want it to be parallel, meaning it would never ever touch it. Okay, Abby.
The other line.
What?
Looks like the pink line.
The pink line is this equation. So we want it to be parallel to this line. And so I do that just so you guys can see what it looks like. Now parallel means it'll never touch. So what do we know about the slopes of parallel lines? We said they are the same. So if we know the slope of this line, do we know the slope of the line that's going to be parallel? Yeah, so do we know the slope of this line of the pink? Yeah, because it's in slope-intercept form, right? This is in our y equals mx plus b form. So what is the m or our slope here? 1 over 3. Meaning that our parallel slope, so I'm going to put an m. I'm going to put a small little parallel symbol behind it. Just to say this is our parallel slope is going to be 1 over 3. Now, if you guys recall, okay, when we graphed slope-intercept form a few classes ago, okay, we did that on Monday. When we graphed slope-intercept form, we would begin with b, and then we'd use slope to make 2 more points. Do you guys remember doing that?
Yeah.
Okay, we'd begin with b, and then we'd use our slope to make 2 points. Well, now what we're going to do is we're going to begin with this negative 2, 4. Because we know that's a point on the graph. Okay, the only reason we began with b was because we needed a starting point. And in the slope-intercept form, that is what's given. We're given that starting point of the y-intercept. Well, this time we're given a different starting point, negative 2, 4. So I can use the slope of 1 over 3 and make new points from this point. So I can go from here, I can go up 1 and to the right 3. Rise 1, run 3, and make a new point. I could also go from my original, go down 1, and run 3 to the left. And if I connect these, I now have my answer in the purple. And the purple is my answer. I wanted to graph a line that goes through negative 2, 4 and is parallel to the line in the pink. Is this purple line parallel to the line in the pink?
Yeah.
Does it go through negative 2, 4? So we did exactly what was asked. Now, when you are doing problems like this, you do not need to graph this pink line like we did. I did it so that way you guys could see what was going on. That, hey, we got the line that's parallel to this. What I'm asking you guys to do on a problem like this is to say, okay, the line's parallel, so we know it's going to have the same slope. Okay? Then I'm asking you guys to use that slope and a point to make a new line. So really the only 2 things you needed for this problem, where I'm going to put them in yellow here, were this point and this slope. Those are the only 2 things you needed for this problem. You needed the point and you needed the slope. Because it's parallel, we had the same slope as the line that was given. Let's try another example. I know some of us are still confused, okay? We're going to try another example because I think that'll help. Okay, I really do.
So do we do 3x minus y equals -2 like we did in the equation of homework?
Great question. We're actually going to do it differently, okay? We're going to go back to how we did a few classes ago. Okay? So we're going to graph a line through 1, -2 that's parallel to the line with the equation 3x minus y equals -2. So we know it's going to be parallel to a line, meaning it'll have the same slope as a line. Now, what point does this line we want to graph go through? It says it goes through 1, -2. So let's graph 1, -2. Let's let that be the first thing we graph. It goes through that point, so let's have it go through that point. So we plot the point, 1 comma negative 2. 1 to the right, 2 down. Now this equation at the end, we're told it's parallel to this. Well, if we have the point, we need either slope or we need more points some other way. If we have the slope, we can make more points by counting rising and running. Well, we know parallel lines have the same slope. So if we find the slope of this line, do we find the slope of the line we want to graph? Yeah. So that's big picture what we're doing. So do we know the slope of this line though right now? No, because it's not in slope-intercept form. It's not in our y equals mx plus b form. So what we need to do is we need to take this equation, 3x minus y equals negative 2, and we need to find a slope. We need to find the slope of it. So we need to solve for what variable so that way we can know the slope. Y, just like we did a couple classes ago. So how would I solve this equation for y?
Subtract 3x.
Okay, we're going to subtract 3x. Once again, big picture, we're doing this so that we can know the slope. Because parallel lines have the same slope. So we have negative y equals negative 3x minus 2. Okay, we kept the signs with every single thing that was there. Now, is y completely 100% by itself? Nope. There's a negative 1 with it. So I have to divide by a negative 1 on absolutely everything. And we get a positive y equals a positive 3x plus 2. All those negatives became positive when we divided by a negative. So now, am I able to know the slope of this line? What is it? 3 or 3 over 1. So what is the slope of my line that's parallel? I know I want, what's the slope of my line that's parallel? 3 over 1. It's the exact same because parallel lines have the same slope. Yes, Jaden?
Why would you subtract 3x and subtract it before the negative 2?
Yeah, because in our, we want it to be as close to our y equals mx plus b form. And so we want the x to come before the normal number. So we place the x before the normal number here. Yep, good question. So we're going to use the slope of 3 over 1 because they have the same slope. Parallel line will have the same slope as the original, okay? And we're going to count from our point, 1 comma negative 2. We're going to go up 3 to the right 1. Rise 3, run 1 using our slope. And we can go the other direction, 2, down 3, left 1. Now you don't have to necessarily go one each direction, okay? You could go a little bit differently with your points if you really wanted to, okay? That's just what I have a habit of doing personally. So we graphed a line that's parallel to the other line, okay? And we didn't have to graph the other line. This is our answer in the graph, okay? This graph is our answer. Now I can show you the other line looked like this, okay? The other line that we were modeling off of looks like this.
Will you count as wrong if you do both lines?
No, if you do both lines, I won't count it wrong, okay? So if you want to do both lines just to confirm that they're parallel, like you can see up on the board now, okay? The purple being the one we worked out in purple and we had to solve to get the slope, okay? And the blue being the one that's actually our answer, okay? I won't count you wrong if you do both lines, okay?
Circle the right answer.
Nope. I'll be able to tell which one's which as long as you do your work. I'll be able to know. Okay. Questions on this? It's a little weird, okay? But really what we're saying is we know a starting point. This time it's different than B, but we know a starting point. So we need slope to make more points. Well, if it's parallel, it's going to be the same slope. Know the slope? Use the same slope. Call it good. Questions before we move on? Okay. Perpendicular lines are lines that intersect at right angles. Does anyone know what a right angle is?
Right.
90 degrees. Okay, it's a 90-degree angle, okay? For a symbol, okay, we do like an upside-down T. Mr. Costa, why is it an upside-down T? Great question, okay? If we look up at the top right corner here, and I draw a full-fledged, does that kind of look like perpendicular lines?
No.
Would that create a right angle, maybe right in there?
Yeah.
Yeah, but it also looks like a plus sign, doesn't it?
Yeah.
So that gets confusing. So we took that and we erased the bottom half. We just erase the bottom half there, okay? And we call it perpendicular lines.
Don't you have to like draw like a square like in the corner?
Yeah, to signify a right angle, you would draw a square in the corner, a little square in the corner of it. But this is just the symbol, so you don't have to do that in the symbol though. Okay, where do we see perpendicular lines in the real world? Raise your hand for where we see perpendicular lines in the real world, okay? Okay, Courtney.
Never mind.
Okay,
Yes, Courtney.
Abby.
Roads.
Okay, roads, at intersections, right? A lot of times they...
I thought I was wrong.
Okay. Isaac. Okay, my board, we see a lot of perpendicular lines there, okay, in the corners, okay? Yes, Raquel. Okay, a triangle, sometimes, okay, if it's the right triangle, okay? Yes, Emily.
Literally anything square or rectangle.
Okay, literally anything square or rectangle, okay? Okay, so like cupboards, like the corner of the flag, okay, posters, ceiling, okay? That was like the most deadpan answer ever, okay? Yes, Alice. Okay. Ellie. The poster? Yeah?
The frame on it.
Yeah, the frame on the poster. Okay. All right. So we said the slopes of parallel lines were the exact same. Okay. Slopes of perpendicular lines are a little bit different. Okay. They are what we call opposite reciprocals. They're opposite reciprocals of each other. Okay. Now, opposite, I want you to write this in parentheses underneath it, okay? We're talking about the opposite sign. So maybe like plus and put a minus. Put a plus and a minus sign underneath that, okay?
1, -2.
No, it would be more kind of like a positive one compared to a negative one. Okay, so a positive and a negative number. So it's not like an ordered pair. I get what you're saying, but it's not an ordered pair, okay? It's kind of written like that maybe. So maybe we take out the comma if we need to. Let's put plus minus, so we don't think it's that, okay? Now for reciprocals, okay, this would be like 1/5 and 5/1. Okay, that'd be like 1/5 and 5/1. So we want it to be the opposite sign of the other slope, and we want it to be the reciprocal version, the flipped version.
The same number, but as a negative.
Yep, and flipped.
Oh, flip
We want
it.
the opposite of the number. The opposite of any number is just you change the sign. The opposite of 5 is -5. The opposite of 2 is -2, okay? Yes, Abby?
For like the opposite, like the plus and minus, can we put a number?
Yeah, sure. If you want to put like +5 and -5 or any number in there, that'd be a great idea. Okay? Now, vertical lines and horizontal lines are perpendicular, okay? So if a line's perfectly vertical and a line's perfectly horizontal, okay, those are going to be perpendicular, okay? Now, the reason why is vertical lines have a slope of some number over 0, and horizontal lines have a slope of 0 over some number.
Pop quiz.
So those are reciprocals of each other. And can you make 0 negative? No. Okay, so those are as close to opposite as they can get for signs. Okay, and they are reciprocals of each other. That's why vertical and horizontal lines are perpendicular. They do make right angles. Okay. Now, if we have this slope of 2/3, what would be the opposite reciprocal of 2/3? Okay, Abby?
The opposite.
Yeah, opposite reciprocal.
3/2.
Okay, and it's a -3/2, okay? We have to put a negative on there. So the reciprocal is 3/2, but the opposite is negative, okay? Because it's positive, the opposite is going to be negative, okay? Right, Josh? Okay. So what would be the opposite reciprocal of -4? Okay? Nope. 1/4. And it's a positive, though. The opposite of a negative is a positive. The reciprocal of 4, which is secretly 4/1, is 1/4. Okay? So the opposite reciprocal of -4, which is secretly -4/1, is positive 1/4. What's the reciprocal of positive 1?
-1/1.
-1/1, but isn't that just -1? Yeah, so -1/1, or you can just put -1. Now on any of these, does it matter if the negative's on the top or the bottom or out in front? No, the negative, as long as there's one negative on the fraction, the entire thing's negative, okay? Abby?
Only one that we don't have to put like in the fraction is 1.
Yeah, I mean, -4, if we were given a slope of, like maybe if we had like another example on here, okay? And we had the example of, 1/5. Well, the negative reciprocal, the opposite reciprocal would be negative 5. Which you could put over 1 if you want, but you don't have to. That makes sense? Great question, okay? Courtney.
So you're saying like for positive, for like negative 4s, you can do just 4. What happens when
This one has to be 1 over. Yeah, because 1 over 4 and 4 are not the same thing. Yep. Okay. All right, moving on. We're going to try basically the same idea. Okay. But now we're going through a point, but it's perpendicular to the line. Okay, so it's perpendicular to a line. So our first step's going to be the same. What was our first step on our other couple problems? Courtney.
you graph the negative 6, 2.
Yeah, it's going through this point, negative 6, 2. So let's have it go through this point, negative 6, 2.
I swear, how did you do that? I keep going the wrong way.
I do too, Ellie.
Okay. So it's x, y.
Oh.
It's x, y. It's alphabetical.
I keep forgetting that.
Okay. Yep.
Which axis?
Okay. X-axis runs left and right. Y-axis runs up and down.
3, 4, right? 1, 2, 3, 4.
Yeah. 1, 2, 3, 4.
Yeah.
Yep.
And I should have
Yeah. What?
I keep mixing up when you with slope.
Oh yeah. Slope. The rise to the top,
That's what I
but the coordinate it's alphabetical. Okay. So we know we have this point, and it's perpendicular to the line with this equation. Y equals 3/2 x plus 8. Now we have a point, so now if we have the slope, we can make more points. Well, we know it's perpendicular to this line over here. Y equals 3/2 x plus 8, which would be, if we were to graph it, would look like this, which you don't have to, but you can. Okay, if we were to graph it, the y equals 3/2 x plus 8, it would look like this.
I did it the other way though.
It's positive.
Yeah.
Oh, excuse me, it is positive. Thank you. This cost me a noof.
That's an extra form.
Yes, there we go. Good catch, you two, good catch. Okay, it would look like that. Thank you. Okay, so we want it to be perpendicular to this, okay? I'll even continue the arrow on. Okay, we want it to be perpendicular to this. So what do we know? We know this slope is 3/2. What do we know about the perpendicular slope? I'll put M and I'll put a little perpendicular symbol, just kind of like we did how parallel slope. We'll do the perpendicular slope. What do we know about the perpendicular slope? It won't be 3/2 anymore. It won't be the same.
Negative 2 over 3.
Negative 2/3, the opposite reciprocal. So now we use this new slope, the negative 2/3, opposite reciprocal, from our starting point, negative 6, 2, and we make more points. So we could go down 3, right 2, or up 3, left 2. And if we connect them, do we notice that these are perpendicular?
Yes.
Yeah, they do intersect at a right angle there.
Intersect at right angle.
Okay? Yes, Jaden?
Wait.
So, I'm kind of confused. We've been
Yeah.
starting from the initial dot that we
Yeah.
plotted, and then we've been starting away from it. How do we know?
Yeah. So, are you talking about this problem compared to other sections?
Well, yeah, because in the previous one you plotted it on the line.
Yep.
where it
Yep.
started, but-
So we need starting points somewhere. So back in 4-6, our starting point was the B, our y-intercept. And then we use slope to make more points. In this section, our starting point is saying it goes through this point. So we're going to go through this point, and then we're going to use slope from there. Now the section we did in between, the one that was due today, okay, we didn't have any starting points at all. So we had to go and create 2 points, which were on the axes. Does that make any more sense?
Yeah.
Okay, thanks for asking that, Josh. Oh, yes. Good riddance. Okay. So who else is in band that needs to go? Okay. Okay. So anyone that would need to go, come get a worksheet from me real quick before you leave, okay?
I think there should be no over.
Now, no, okay? Moving on to the next one. Graph the line through 2, 1, and it's perpendicular to the line 2x minus 3y equals 3. So what's going to be our first step here?
2 over 1 now.
Graph the 2, 1, 2 to the right, 1 up, because it goes through this point, 2, 1.
So the 2x minus
Okay, so let's think about what we're doing. Okay, so to answer that question, I'm going to say, well, what are we doing? We know we have a starting point, so we need the slope to make more points. We only have 1 point, so we need slope to make more. So we know it's perpendicular. So we can, if we found the slope of the line it's perpendicular to, could we find the slope of the line we want to graph? Yeah, because they'll be opposite reciprocals. So we need to find the slope of this line. So do we currently know the slope of 2x minus 3y equals 3? No. So what do we have to do in order to find the slope? Solve for y. Okay, like we have been doing. So how would I solve this one for y?
Take away 2x, 3x. Oh, not 2x.
Yeah, subtract 2x. So negative 3y, we'll put the negative 2x first, so that way it's in slope-intercept form. Plus 3, because the 3 is still positive. Now we divide by negative 3, like we have been doing. Negative 3y divided by negative 3 is y. Wait, does negative 2 over negative 3, does that reduce? No, but it does become positive, right? Because the negative divided by negative is a positive. So we have 2 over 3 with the x. Minus 1? 3 divided by negative 3? So what's my slope of this orange line? 2 over 3 is my slope. So what's the slope of my perpendicular line? Negative 3 over 2. It's the opposite reciprocal. I'll go back through that in a second here. Okay, so we had our initial point 2, 1. Now we need slope to make more points, because we only have one initial point. So we know it's perpendicular to this orange line. Well, if we know the slope of this orange line, we can find the slope of our blue line. We had to find the slope of the orange line to be 2 over 3. So we know it's the opposite reciprocal. 2 over 3 becomes 3 over 2. Positive becomes negative. So now we use that slope to make more points. So we go negative 3 over 2. So we go negative 3 down, 2 to the right. Or we go 3 up, 2 to the left. It's a negative slope, so it should look like it's going downhill.
How did you get? Wait, which one are we graphing?
We're graphing the negative 3 over 2 slope, because we want the perpendicular line. This blue line would be our answer. Now we could also graph the other line if we wanted. You don't have to. Which can showcase that they are in fact perpendicular.
Wait, so then why do we need, so you use the 2 over
Okay, so we had to find this 2 over 3. So we could find the negative 3 over 2. We had to use the orange to get to the blue, because we know it's perpendicular to this orange line.
You don't need to graph this?
You don't need to graph the orange, but we need to graph the blue. The blue is our answer. Elijah.
Why do you have to solve out this equation? The last one we did.
Great question. So the reason why we have to solve this equation is, do we know the slope of this equation by looking at it? No, because y is not by itself. But the previous equation, we knew the slope right away because y was by itself. Great question. Great question. Did I answer it? Okay. Any other questions?
Why does it have
Okay, I'll look at that individually in a moment, okay?